Guys, welcome back to this lesson. So in this part of the lesson, we want to look at how you can manage hallucination in LLM. So like we said in the previous lesson, LLM can hallucinate because they are traced on open source data. And when you are using what is traced on open source data for a particular company, maybe oil and gas or bank, that's the capability of bringing many information from other companies, from other sources, from open source, whether relevant or relevant, and then apply it to your use case, and then you have hallucination. So hallucination is when the LLM generates, information that is not true, or that is slightly deviated from being truth, or does not apply to your use case. So that is hallucination. So selecting, oh, sorry. So let's look at what we have in this uh, case. Selecting models by task complexity. We've talked about this before, so we just run through it. Selecting models by task complexity. We have three categories here: task, complexity, and recommended model. So we consider the task, we consider their complexity, is it simple or hard, and the recommended model. So for sentiment analysis, for example, sentiment analysis is easy. So it uses a kind of a clustering model, unclassified machine learning. So on classification model, that's what they use. An example is clustering, and in high cases, can use a recommender system or neural network when it's becoming hard. So sentiment analysis is an unsupervised model which still belong to low level. So the complexity is low. So for this kind of task, you can use small encoder. Or let me just use an example. You can use Claude IQ. Then data extraction, this is medium. So it doesn't involve high reasoning or high decision making. So or for data extraction, which is medium, you can use small language model. An example is Phi 3, Microsoft, Phi 3 or Phi 4, and Llama this thing. Yeah, if you are a data engineer, if you are a data engineer, you can also be a product engineer. Let me just say, I am a data engineer. Now I'm teaching here Agentic AI Product Management. So here, if you have worked in Databricks before, you see that the AI in Databricks is Llama 3 or Llama. It's a form of Llama, which is a small language model. Its task is to generate code and data analysis using PySpark or any language that you want to use, SQL, R, or Python. So for data extraction, you can use small language model like Llama 3 for strategic planning. So task that requires reasoning, acting, planning, sequential execution, chain or processes. It follows process. It is high because it involves higher cognitive capability. So here you can use large LLM like GPT-40. Okay, you can use large LLM like GPT-40. You cannot immediately switch to GPT-5 or 5.6. Start with GPT-4. GPT-4 is a large language model, and of course it's still even very effective in some tasks than even GPT-5. Okay, so for strategic planning, go for model like GPT-40 large. Then for code execution rather, not code extraction or generation. So code execution involves planning, data extraction, and analysis, because the agent should be able to generate code, it should be able to combine it together, it should be able to know what to put together, which design to use, Python architecture, Python principle, which modules to call or modules to use, and which function to write. So coding is a very high cognitive task, and for those kind of situation, you can use specialized coding model So you can use specialized coding model like Codex for ChatGPT and Cloud Code. Okay, Cloud Code Cloud Code and Codex has been known to be very effective at building application from scratch. All you just need is to identify the problem, provide the use case, and they generate the front end, back end, build the whole system for you, and then you can even deploy if you give access, and then you have your full application. So these are ways of selecting model based on task complexity. Remember, implement domain-driven design. For simple task, design simple application, use simple model. For complex task, design complex application and use complex model. All right, guys, so this is what we have here on this slide. We have effective prompt use structured component. So effective prompting is just putting the right prompt into the system, using the right prompt with the right example, few shots, or using just only information, which is 0 shots, but most of the time you can use a few shots. Okay, so these are ways of getting the best out of your LLM or SLM. The first one is role playing or persona. You can give the agent a persona, e.g., you are a software architect. If you want to perform a software architect task, you tell the agent to act as a software architect. If you want to build a backend application and you want the agent to build it, just tell the agent to act as a backend engineer expert. If it is Python code that you want to write, you tell the agent to act as a Python developer, expert Python developer. Most of my UKs, I write book, so I normally tell the agent to act as a, professor in that particular field, so that it gives me the best information, okay, that I can ever get. So you can give the agent a persona, e.g., you are a senior compliance auditor, you are a supply chain manager or supply chain analyst, you are a procurement manager or procurement analyst, you are a security engineer or IT operation engineer, etc. Those are ways of defining persona. Then the next thing you can use for effective prompting is objective. So give the agent objective. Refill this contract for missing clauses. Okay. Do not just say refill this contract. Add the objective. What is he reviewing for? It can just review and give you all possibility of the outcome. But if you want to narrow it to a specific outcome, you can just narrow it to what you need. Refill this contract, and find me the highest, highest, one generating a financial benefit, okay, or refill for missing clause, or refill for missing POs, etc. So you can use objective. Another thing you can use is constraint. Okay, so constraint is limiting the agent action to a particular task or a particular boundary. So do not mention pricing, only focus on risk. Okay, so you want to generate information maybe on a particular product. Okay, so and then you just say find every information in on this product, and then it find you all the information, pricing and everything. So but if you want to narrow it, just say do not mention, you give it limit, constraints, what it should do and what it should not do. Okay, and what you should focus on in the output. And then we have output schema. Return a JSON object with key, risk level and summary. So you can define the output schema. For example, if you want your output in tabular form, you can say tabular form. If you want it in graphical form, visual form, you can say you should generate a particular graph, maybe bar chart or pie chart. If you want it in Excel format, so some AI now have the capability of generating Excel file, document, PDF, and even PowerPoint. So it can generate the answer in any form. If you want it, for example, I am also a developer. So when I want to develop application, what I tell the agent to do when I give it all this, give the description of all the application, everything, I will ask it to develop the architecture, the software architecture, the development architecture, the code files, front end and back end, testing, end-to-end testing, integration testing, and unit testing, and then deployment file. everything packaged together as a zip file that I can just download. And that is what I use. So I just download, open in VS Code, debug, and deploy application. An application that I can take 1 month to do, I can build it in within 5 hours and deploy it, okay, under this, instead of generating different files that you not know how to organize. The agent can help you organize everything together into a zip folder. Then you just download, review, and deploy. All right, so we are still on prompting. Few short prompting. I've been talking about this one several times. Of course, you should know the meaning now. So giving the agent instruction with examples is called few short prompting. So this teaches through example. Few short prompting teaches the agent or the AI through examples. An example is demonstrating the golden path to ensure consistent behavior. Okay, so you give it example here, golden path to demonstrate consistent behavior. So examples allow the agent to fashion your, input using the example. It fashion it in the pattern of the example. Instead of generalizing the output, it only fashion the output based on the examples that you have given. And when you are implementing field shots, teaching the agent through examples, make sure you give the right example. Okay, so just like if you teach a primary school student a foundational class that doesn't know left from right, you teach them wrong thing, they will keep to that wrong thing. Even when they get home and their parents are saying, oh, this is wrong, this is wrong, they will tell you, oh, my teacher says it is right, or my teacher taught me. Because why? They believe that the teacher is a professional, okay, and should be saying the right thing than the parent who they see at home every day, which are not professional in the aspect of teaching. So that's how that works. Even let me use the case of psychology, or a counselor, for instance. You go to a counselor gives you wrong advice. Maybe a quack counselor gives you a wrong advice. You apply the advice, then you get home. Maybe you are a secondary school student, school counselor have counseled you. You get home, your parents is saying this is not right. You say the school counselor taught me this. You believe that the school counselor is a professional who know what is doing than your parent who is not a professional in psychology. So that is how it's work. So when you are teaching agent with example, use the right example, use accurate example. Okay, so style alignment, we have shown the agent exactly how the company writes reports. Okay, so ways of teaching agents through example is style alignment. So you can use the company format. Maybe if you want to build a dashboard, or the agents will be building dashboard, for instance, visualization or reports, you can upload the report formats together with your prompts. Okay, so the report format will now serve as an example together with the prompt that you are giving the agent. So showing the agent exactly how the company writes reports, format of generating documents, or format of generating Excel file, PDF file, document file, PowerPoint, PPT, or graph, color, company custom writing. That's style alignment. Then we have risk classification. Okay, this is providing examples of what counts as high risk. So if you just give the agent prompt on general risk, it may not be able to classify the risk. So the agent must know how to classify something as high risk or low risk. So by giving example, give examples of what is high risk and give examples of what is low risk. Then the next one is edge case handling. So this is teaching the model how to respond when data is missing. Okay, so you are deploying at the edge. The agent is already working at the edge. If there's missing data, how does the agent identify it? So teach the model how to respond when data is missing. How will it respond when there is no data? How will it respond when the information it needed to perform its task is not available? Instead of hallucinating, you can use these cases. So the first one is style alignment, risk classification, edge case handling. Then we have decomposing reasoning into stage pipeline. How can you design for this? How can you design agent to decompose reasoning into stage pipeline? Remember, you are designing for a business domain, and every business domain have their process. There's what we call process mining and process intelligence. So process mining is generating business data and business metric and using them for data science analysis and business intelligence. And process intelligence is deriving value from the company data that we have obtained through process mining, taking reasonable decisions, optimizing business outcome, business value, generating income, and lowering cost is what we call process intelligence. So mining plus intelligence is called the business process management. So you must know about business process management. You can get one of the book. Maybe I'm still going to explain more on that when we come together. So even when you are combining reasoning, you must still implement logic. Logic is very, very important. Logic enables the agent to distinguish between what is right and what is wrong, the action it should take and the action it should not take, the action it should combine together, and how it should combine them together. That is logic. So we have process intelligence, process mining, and computational logic, or even with human logic combined together. So that forms an advanced form of system thinking. Okay. So informations task must be able to be broken into process. That's why we said earlier that you should understand process, work on process, not on task. Okay, task is one unit. You should be able to break the tasks down into processes. For example, in data engineering, we have data engineering as a task, which is the aim is to get data from various sources, transform and model the data, and store in the warehouse. So you can break it into extraction, transformation, and loading, governance, and analysis. So that's how you can, that's data engineering process for you. So here, to decompose reasoning into stage pipeline, you can use this example, chaining. So using the output of one prompt as the input for the next one. So instead of just putting all the tasks as one instruction, you can break the task to several instructions, maybe instruction 1, 2, 3, 4, 5, and then 1 should come before 2, 2 before 3, 3 before 4, 4 before 5. Then you can break tasks into chains or into individual unit, change them together as a prompt. Then you can also use validator agent, which is a second prompt that checks the first one's work. So a validator agent, you have a prompt that is implementing chaining. This is actually called chain of thought. Okay, if you've read generative AI design, one of O'Reilly's book, chain of thought is one of the agentic system design, or one of prompt engineering principle. We have chain of thought, we have tree of thought. Okay, so validator agent will validate whatever the output of the stage 1 is. Okay, so a second prompt that check the first one's work. So the agent implementing chain of thought will not just conclude and send to the planner. Whatever the conclusion of the chaining is, it is sent to validator agent. So validator agent validates and check the correctness of the output. Then if it is correct, very correct and accurate, it send the information to the planner executor agent. So this planner executor agent will now separate the decision of what to do from doing. So it separates it. This planner agent acts, it reason and then acts, decide what to do and what not to do, and then send the information to wherever the task needs to be executed. So robustness, breaking down one large task into 5 small ones increases accuracy by 30%. So do not just put a whole task as one chunk of prompt. You can break it a very large task into 5, into 10, depending on the complexity, and then you can chain them together in sequence, and then give it to an agent, pass it through validator agent, executor agent decide what to do, and then hit there. It will help you implement accuracy, task accuracy, and robustness in system design. Then we have self-consistency and reflection techniques. So how do you design for self-consistency? How do you make the agents to be self-consistent, to be capable without even depending on other agents or on human? and reflection. How do you design for reflection? When the agent just does something right, how does he reflect on what it has done and do it better the next time? When the agent does something wrong, how does he reflect and call itself to correction? Okay, so these are the design example for that. We have multiple iterations. So generating three answers and picking the most common one. So this is tree of thought implementation that I told you in the previous slide. So you can have the agent generate three answers and pick the most common one. So based on the example that you have given or the chain of thoughts prompt that you have given, you can have the agent iterate through the examples, through the chain of thought, and generate 3 or 5 examples, and then you pick the most common. Okay, so we have self-critique. You can design the agent to critique itself, to self-reflect, to perform a task, check through the task, and decide whether it has done it well or not. So this is asking the model, what did you get? What did you get wrong in the previous step? Okay, and then we have refinement. So this is allowing the agent to edit its own work before the user sees it. So all these agents, all these things can be implemented by agentic system even without human control. Okay, so we have multiple iteration, allow the agent to iterate multiple times, generate various outputs and pick the best. Self-critique, the agent reflect on what it has done and check whether it is right or wrong. And then refinement, the agent has the capability of correcting itself, calling itself to order when it goes beyond the boundary or when it implements a wrong task. All right, so on this next slide, we have prompt engineering as a software engineering. Okay, in my video on mass, or in my multi-agent system engineering book, I said there that prompt engineering, treat prompt engineering as software engineering. Do not teach prompt engineering as just an instruction or a readme file that doesn't need to be fashioned, or just a skill that you give once and forget it. Okay, because business metric changes, and when business metric change, your prompts should also change. When business metric move from simplicity to complexity, your prompts should also accommodate the complexity. So business prompt is not rigid, it is flexible, it is iterative. So you should also bring lean and agile methodology into your prompt engineering design. So prompt engineering must be treated as a software engineering. It must be fashioned, it must be tested, and it must be included in the pipeline for updates. Okay, so the first thing we have here is why you should treat prompt engineering as a software engineering is a fashioning. Okay, so strong prompt, store prompts in Git repository to track changes over time. You do not just store prompt on your desktop or on your laptop and then deploy the code. No, store the prompt also with the code, with the product in Git, with the product code in Git repository, so that you can track changes. Whenever there is change, you just go there and update the change and then create a pull request again. Then unit testing, running every prompt change against a fixed set of tests. So every prompt must be tested. Okay, just like, let me give this an example. So if you are a human resource, if you are a human resource person, sorry, I wanted to say human resource engineer. Everything is engineering now, okay? Of course. So if you are a human resource manager and you want to hire a data analyst, the first thing you do is when you send out application, they apply. So anybody can apply, a data analyst or someone that doesn't even have the knowledge of a data analyst can change their CV and say they are a data analyst and then apply. Then you get all this application. The next thing you want to do is interview. Okay, you do oral interview and you do written interview. So oral interview is assessing maybe the communication capability of the person. You assess the person, you assess their communication style and everything, assess their mental reasoning, how they talk, how they do things, and then written. So you can give them a particular task, maybe a data to model, transform, and plot Power BI, dashboard, create a report, visual report, and see whether they actually have the capacity to do the work. So also you run your prompts through unit test. Test the prompts whether it is actually accurate. What you are using as prompt is the skill of the person you are designing agent for, the skill of the particular domain you are designing the agent for. So you should also test the prompt based on the domain. Okay, so running every prompt change against a fixed set of test cases is called unit test. So test every uh, aspect of the prompt. So we have said that you can implement chain of thought or prompt chaining. So when you break down a task into different chain 1, 2, 3, 4, 5 up to 10, then make sure you test every chain. Test them. Test 1, test 2, test 3, test 4, and then do the overall end-to-end test again. Okay. Then CI/CD for AI. This is automatically deploying new prompts only if they pass quality gates. So implement gated pull requests. So or there's in DevOps, there's what we call branching. So we have the master branch where all the codes to be deployed are. We have the staging where the code is being tested and passed through quality assurance before moving into the master branch where it is deployed into production. And then we have the development branch, which is where all the developers put their code to, or after when they develop in feature engineer also, or they develop in feature branch, and then they develop in development branch, push to feature branch. From feature branch, it is put to staging. After testing in staging, then it is deployed into the master branch, and then a CI/CD pipeline is triggered in order to deploy into production. So when prompts are stored in Git repository, they also pass through the CI/CD process, which enable the application to pick up on the new prompt and drop the old one. All right, how do you control token efficiency is the next thing we have here. So remember, token is the usage metric of the LLM. How the LLM is being used, the amount of cost is generating, the amount of token is using to perform a particular task is called token. So controlling token efficiency, spending less while getting more capability. The first thing is context pruning. Okay, instead of giving a large context or large instruction, remove irrelevant data, implement lean approach to save money and model focus. So when you give too much instruction, the agents normally just use maybe what is in the the first part of the instruction and the last instruction, and then instead of generating various unrelevant information, summarize the context. Okay, capture the relevant information so that instead of the LLM spending a lot of time running through all the instruction, it just captured the relevant information because you have few instruction, and then it work faster than wasting token on understanding your prompts. Then we have templating. So this is reusing successful prompt structure across different agents. So prompt template, when you see that a particular prompt is working very well, you can template and store the prompt so that you can reuse it for another agent if it applies. Then we have input compression. So using SLM to summarize data before sending it to large LLM. So you can summarize the data using small language. You can use haiku to summarize, then you can send the output to a large language. For example, if I want to use Codex or Cloud Code for example, I go to GPT, put my instruction there, everything, GPT refine it, reduce it, compress it into relevant information and reduce it. Then I just copy and paste in Codex and Cloud Code, and they begin to code instead of them. They are designed to code. Instead of them wasting time to understand, GPT has refined the instruction to what is relevant, and then they just begin to work instead of thinking and wasting token. So there's also what we call token maxing, which are practicing in Google and most companies now, which enable them to maximize output and minimize costs. So all these are token maxing that we just discussed. Okay, so the Cadaver prompt registry architecture. So I told you my Cadaver is my product, is an agentic architecture framework that already include planning, reasoning, predictive analytics, recommender engine, neurosymbolic architecture, and it has chain of thought, tree of thought, governance policy, and everything, distributed microservices and domains can be integrated to domain. So all you need is to bring your agent and deploy it on the architecture. But to refine the agent, we still have to use the company policy as well. And then it has a layer where you can connect to business applications, ERP system, database, and all that. That's a layer. We have the agentic architecture layer, we have the cognitive layer, then we have the agent layer, which is where you deploy the agent, and then we have the operation layer where you observe, collect metric, and we have the user interface layer where user uses it. So it has two user interface. One is observability interface, and one is the user interface. Observability is meant for site reliability engineer so that they can check what is happening in the system, and the user interface is where the business user can actually interact with the agent. So the Kadaba prompt registry architecture looks like it contains, these are a few things that are there. Okay, my Kadaba architecture contains a lot of things. We have for the architecture layer, for the brain layer, there are about 10 agents, and then for the integration layer we have other 10, and then for the governance layer we have about five of them, and then for the agentic AI layer, you bring your agent, can be 50, can be 100, can be any number of agents, then you just deploy it on it. So every company needs just a single Kadaba architecture, except except of course that every business domain have their policy or governance. But as long as the company, as long as an enterprise is using one company, operating under one policy and governance, all you need is just one Kadaba architecture, one Kadaba framework, and every developer can be deploying agents or on the framework based on their domain. So the first thing the first thing included in the architecture is authority. What can this agent do? So in the Kadaba architecture, what the agent can do is already there. We have tools. So these are MCP tools that allow the agent to connect to applications, connect to external knowledge or website. So what API does it have access to? So it must not be designed also to have access to every API. Okay, governance and guardrail is included. Then prohibited action. These are the limits of what it should not do. Okay, so what limit of what it can take? So it must have limits on what it must never do, what it must never carry out. Okay, and then escalation. When should it escalate a particular information? Okay, so when should it stop and ask human to approve or to check through? So these are the various design, okay, that is designed to mitigate risk in the Kadaba prompt registry architecture. And then here we have so we have what we call the zero shot versus few shot. So I've talked about this many times. So the zero shot is summarizing summarize this email. Zero shot is just giving the LLM an instruction without example. Then few shot is giving the LLM an instruction with examples. Okay, so those are the difference between zero shot. So it's one, will not spend more time because I've been explaining this from the beginning of the slide. So zero shot, example of zero shot prompt, summarize this email, no example, no what to look for. Then few shot, example of few shot, summarize this email in the Kadaba executive style. Okay, or summarize this email in my style, or summarize this email and find what is relevant to my product price, etc., with example. Okay, and then the next thing we have here is managing hallucination through constraints. So we have talked about different constraints that you can set and how to set them. The next thing we have here is how do you manage hallucination through controls. The first thing you should measure is groundedness. Okay, groundedness check whether answer whether the provided test is accurate. So when you use groundedness, which is one of the RAG measurements, groundedness and relevance. So you check whether the information is grounded in the company information. You check whether the output is relevant, or what the agent has done is relevant to the business value or business process. So in groundedness, you decide the agent to not angel, you decide the agent to answer only using the provided test. It's only answer in your style, or it only answer based on what is in the RAG database. That's groundedness. So you can use this to manage hallucination. The negative constraints: do not make up facts not in the source. So you can set a constraint that the agent should never use any fact or any information that is not included in the source. And your source can be your file, repository, SharePoint, or data lake, warehouse, or your RAG database. So any information that is not in your company or repository should never be included. Even though if it is a fact, it should never be included in the output. That's another constraint you can set. And then another one is confidence scoring. So asking the model to rate its own certainty on a scale of 1 to 10. So allow you to test the confidence. Agents never lie. They cannot lie. You design them, and if they are lying, it's on the developer that has designed it to lie. You understand? So to set constraint, mitigate against hallucination, use groundedness, use negative constraints, and use confidence scoring. Okay, so these are the three we have. So guys, we'll be stopping here now. Thank you for listening. And please, if you are just coming, encourage your girl, subscribe to this channel, and refer someone, okay, to this channel to also subscribe. Thank you for listening.